Okay, so I'm going to go over a few parts for the limiting reagent activity. For those of you who've had my class, this should be something familiar to you. We did this before in second semester. Did a little bit different than we did here. So this is what it looks like. And let's go and look at your stuff. So you're going to be given a card. And so I'm just going to put down that I have card number 8. And I'm going to record my values on my card are 15 millimoles of copper 2 chloride and 15 millimoles of aluminum. So before you can even get ready to do your lab, you're going to have to actually figure out how much substances you need. And if you read the lab or the activity, we're going to be using 0.5 molar CuCl2. And so you have to come in that day prepared to measure out your copper 2 chloride and your aluminum full. So let's review how to do that because it's been a little bit. So I'm going to start with the copper 2 chloride. Okay, this is the one that might give you a little trouble. Don't get messed up with the micromolar. So I'm going to start with the 15 like I always do. Okay, so 15 over 1. I want to get that back to something that I'm familiar with. And if I recall right, little m means that we have 1,000 to 1. So I'm going to put 1,000 millimoles on bottom with 1 mole on top. That gets me back to the 1 mole. Now, this is a step that is usually missed. We have to remember that when we read a bottle and it says 0.5 molar, we can also represent it as 0.5 moles per liter. Okay? So if we have that in mind, then I take this number here and I'm going to put the moles on bottom, liters on top. Now, product at the top divided by the product at the bottom. And when I do that, I'm going to get 0.03 liters. Reality check, I'm not going to be measuring out 0.03 liters. I'm going to use a graduated cylinder that uses milliliters. And so I'm going to convert my liters back to milliliters by using 1,000. And what I get is I'll need 30 milliliters of 0.5 molar copper 2 sulfide. Sorry, copper 2 chloride. And so when I come in for that activity, I already know how much I need. Okay, so you'll put your number in and you'll apply the math. Okay, then we got to figure out how many grams of aluminum that 15 millimoles of aluminum is, or whatever the number is on your card. So again, this first step is the same that I did on the other one. I'm going to convert over to moles of aluminum. Once I've converted over to moles of aluminum, then I'm going to use my periodic table and I'm going to find that it's 27 grams to 1 mole. That's where that number comes from. That comes from the periodic table. Then, product at the top divided by the product at the bottom. And I'm going to get a fairly small number, less than 1. So, when I walk into my activity, I already know this is how many grams of aluminum I need, and this is how many milliliters of copper 2 chloride, 0.5 molar, I need. So let's look at the rest of this, because you got your measurements, and that is what you need to walk in with, ready to go. Here's the rest, going down memory lane. Okay, observations, it's going to be various depending on what you have. I want to see you come out with the color, maybe a texture, if there's any smell, odor, all that. Your balanced chemical equation. Okay, we have a single replacement reaction. We've done this before. We're going to take the copper 2 chloride, we're going to put it in a test tube, we're going to stick that aluminum full in there, we're going to let it react, okay? And if you recall right, Whether it's, I know there's a chemical reaction because I'll be able to feel a change of temperature as I do it. Okay, so aluminum plus copper 2 chloride yields aluminum chloride and copper. I'm not going to spend much time on balancing it. I think you can handle it, no problem. The new one is what we call the balance net equation. Completely new to you. And all I did is what I took your balance equation and now I've put the charge. Because remember, if I'm at a neutral state, if I'm back at my standard state, then it is 0. And I see that I have a mistake here. That is 0. So when I'm at ground state, my charge is 0. So we basically have to figure out who our spectator ions are, okay? And spectators are the ones that stay the same. So if I look, I should notice that this chlorine here and this chlorine here stay the same. There's no change. But the copper and aluminum have changed. And so what I'm going to do is I'm going to go bye. And so my net equation is simply 2Al plus 3Cu positive 2 yields 2Al positive 3 plus 3Cu. Okay? All right, down memory lane we go. Here's limiting reactant. The easiest way to do it is to go from one to the other. All right, so I'll start, and I just chose to start with 15 micromoles CuCl2. Since I'm doing a ratio between one to the other using my balance equation, which is why I need it, I don't care as long as my units match. So I can keep this micromolecule here, millimole, sorry. So I start with the 15. I go to my balance equation. This is what's on top. It's got to go on bottom next. So I get the 3 from the balance equation. I'm going to convert to aluminum. I've got a 2 in front of aluminum. I'm going to put a 2 in front of there. Now I do the product at top. So 15 times 2 divided by 3 gives me 10. I have 15 millimoles of aluminum. So my aluminum is in excess, which means that my copper 2 chloride is my limiting reagent. The other way that we want to look at it is by a drawing. So it doesn't matter if you draw dots, whatever. I drew elements. And I'm not going to be too worried about necessarily the shape on the right side, okay? All right. So I went in here and I drew out my 15 aluminum, 15 copper. So since my equation has that I have 1 aluminum for every chlorine, wow, for every copper, yeah, sorry. Oops, I messed that up. Okay. So what I'm trying to show here is that I'm going to have these 5, and they're going to use up, for every 2 of those, we use up 3 coppers. Okay. So I did that wrong. I'm sorry. 1, 2, 3, 4, 5, 6, 7. Okay. And all you want to do is I just want you to draw out who's getting used up. So for every 2 aluminum, I use 3 coppers. 10, 11, 12. 13, 14, 15. 2, 3, 4, 5, 6, 7, 8, 9, 10. And I still have 11, 12, 13, 14, and 15. And what I'm showing is that I still have extra aluminum. Okay? Don't get caught up on all the prettiness of this. I just want you to start pairing those up and be able to see how much you have left over, which should help you predict what color your solution will be when you get done with your reaction. Okay? Then after that, our lab is comparing our results, putting in a spectrometer, and seeing if we actually match up those results. Okay? So let's see what you can do. Live long and prosper.